Good afternoon, this is Miss Winters. I want to review the STAR biology questions. Let's look at the first one, 35. If you're using the wake strategy, we need to figure out what is the question asking, and then we will write some notes, underline some keywords, and then we're going to eliminate the wrong answer choices. So the question 35 reads, the table shows a DNA sequence and 3 types of mutations that can change the DNA sequence. So we have the DNA codons here, we have the mRNA codons here. Here's the original, AAG. Just out of curiosity, what is that going to code for? A, and G, so it should be lysine. That's what it originally would code for, so you might want to highlight that. Okay, go ahead and highlight lysine. Anything else is a mutation, so let's look at mutation number 1. We have UAG instead of A. We've had a substitution. So UAG, let's see what happens here. We have U, so we're going to be on this row. A, and then G. That is a stop codon. Well, the question is asking us, which mutation will cause translation to stop? So definitely mutation number 1. I can see right away that 3 of my answer choices include mutation 1. So I have 3 possibilities. Immediately you could mark out C as an answer choice. So mark out C. If you're looking at mutation number 2, which is what C is, you can verify that. AAA. A, and A will still give you lysine, so not much change there. Let's look at mutation 3 to make sure that 3 does not give us a stop codon. We have A, G, and G. A, so we're going to be on this row. A, and, oh, it was AGG, sorry. A, G, and G. So it's ARG. So that is not going to produce a stop. That is just going to change the amino acid that it calls for from lysine to arginine. So the only one that will produce a stop codon would be mutation 1. Does that make sense? I hope so. If not, when you get back to biology, make sure you ask your teacher. Now, let's look at the second one. In the second one, we have different types of mutations can occur in DNA. The diagram represents a type of mutation. So what is the question asking? Which statement describes the mutation in the diagram? So this must be my normal DNA, and this must be my mutated strand. They've zoomed in specifically on a gene. As you know, codons are in 3s, base pairs in 3s. So we have GAC, that's our first one. TAG, that's our second one. And CAC, that's a third one. Let's look over here. GAC, that matches here and here. Then we have TAA, well, over here we had TAG. And then we have GCA, and over here, CAC. And then an extra C on the end. Being that there is an extra base at the end, doesn't it make sense to think that this has gotten longer? If it's gotten longer, then it sounds like there has been an insertion. So the mutation is an insertion. However, you see this trick answer right here? Look at F. A silent mutation results in the insertion of a different amino acid. The amino acid, if you scroll, let me scroll up, the amino acids are all of these guys, which would mean you've inserted an entire new amino acid. You would actually have to insert 3 different bases to give you another amino acid. Well, we've only inserted 1 extra base. Remember, we have TAG, and over here we have TAA, and then everything frame shifted over. So you can't insert an entire amino acid. Basically, what has happened is a base is inserted into 1 strand of the DNA, and that is that extra little A, and everything else scooted down. Does that make sense? I hope so. If not, like I said, talk to that biology teacher as soon as you get back. Y'all have a good day.